Vitamin D is a fat-soluble vitamin essential for various physiological processes, including calcium homeostasis, immune function, and skin health. Recent research has highlighted its potential role in dermatology, particularly in hyperpigmentation disorders. This article explores the impact of vitamin D on skin pigmentation, the mechanisms by which it influences melanogenesis, and its potential therapeutic applications for hyperpigmentation conditions. Vitamin D exists in two primary forms, D2, ergocalciferol, and D3, cholecalciferol. While vitamin D2 is obtained from plant sources, vitamin D3 is synthesized in the skin upon exposure to ultraviolet B (UVB) radiation. The process involves the conversion of 7-dehydrocholesterol into pre-vitamin D3, which is then hydroxylated in the liver to 25-hydroxyvitamin D, 25-OHD, the major circulating form of vitamin D. A second hydroxylation occurs in the kidneys, producing the biologically active form 1,25-dihydroxyvitamin D, 1,25-OH2D, also known as calcitriol. The skin itself expresses vitamin D receptors VDRs and the enzyme 1,Ha-hydroxylase, allowing for local activation of vitamin D. This suggests that vitamin D plays an intrinsic role in skin physiology, including barrier function, immune response, and melanogenesis. Hyperpigmentation and melanogenesis. Hyperpigmentation is a common dermatological concern characterized by excessive melanin production. It manifests in conditions such as melasma, post-inflammatory hyperpigmentation (PIH), and lentigines. Melanin is synthesized by melanocytes in the basal layer of the epidermis via a process called melanogenesis. The key enzyme tyrosinase catalyzes the oxidation of L-tyrosine into L-dopa and subsequently into dopaquinone, leading to the formation of melanin. Several factors contribute to hyperpigmentation, including UV exposure, inflammation, hormonal imbalances, and genetic predisposition. Vitamin D's mechanisms in regulating skin pigmentation. 1. Inhibition of tyrosinase activity. Studies suggest that 1,25-OH2D may downregulate tyrosinase, the rate-limiting enzyme in melanogenesis, thereby reducing melanin synthesis. Vitamin D analogs have shown depigmenting effects in experimental models by interfering with melanin production. 2. Anti-inflammatory effects. Vitamin D modulates inflammatory pathways, reducing cytokines and oxidative stress that can trigger post-inflammatory hyperpigmentation (PIH). By mitigating inflammation, it may prevent excessive melanin deposition following skin injuries. 3. Regulation of keratinocyte-melanocyte interaction. Keratinocytes release signaling molecules such as endothelin-1 and stem cell factor (SCF) that stimulate melanogenesis. Vitamin D modulates these pathways, potentially reducing excessive melanin production in hyperpigmented lesions. 4. Photoprotection. Vitamin D enhances the DNA repair mechanism in UV-damaged skin, reducing oxidative stress and the subsequent stimulation of melanocytes. This protective effect may help in preventing UV-induced hyperpigmentation. Clinical evidence supporting vitamin D in hyperpigmentation treatment. Several studies have investigated the link between vitamin D levels and hyperpigmentation disorders. Melasma and vitamin D deficiency. Research indicates that women with melasma often have lower serum 25-OHD levels. Vitamin D supplementation in combination with topical depigmenting agents has shown promising results in improving melasma. Post-inflammatory hyperpigmentation (PIH). Given its anti-inflammatory properties, vitamin D may help in reducing pigmentation associated with acne, eczema, and psoriasis. Topical calcitriol and analogs. Some studies have explored the use of topical vitamin D analogs, e.g. calcitriol, in hyperpigmentation treatment, with mixed results. These formulations may work best when combined with other depigmenting agents like hydroquinone or retinoids. Sources of vitamin D for skin health. 1. Sunlight exposure, 10 to 30 minutes of sun exposure, depending on skin type and location, is a natural way to boost vitamin D levels. 2. Dietary sources. Fatty fish, salmon, mackerel, fortified dairy products, egg yolks, and mushrooms. 3. Supplements. For individuals with vitamin D deficiency, supplementation with D3, cholecalciferol, is recommended, typically in doses ranging from 600 to 2,000 IU per day or higher under medical supervision. Vitamin D plays a crucial role in skin health, including its potential benefits in hyperpigmentation disorders. Through mechanisms involving tyrosinase inhibition, anti-inflammatory effects, and photoprotection, vitamin D may contribute to the management of melasma, PIH, and other pigmentary conditions. While more clinical trials are needed to establish standardized treatment protocols, maintaining optimal vitamin D levels through sun exposure, diet, or supplementation may be beneficial for individuals struggling with hyperpigmentation. Would you like me to adjust the level of technicality or add references?